Hey y'all, it's Ms. Flores. So today we're going to be reviewing multiplication with decimal numbers. Some problems will be dealing with models. Other problems you might just be solving them. So let's go ahead and get started. So our first question that we're going to go over is number 1. These questions are numbered kind of differently. You might have multiple number 1s because they're being pulled from a couple different assignments. So this is the first number 1 that we have. We have that Darby pulls weeds on Friday and Saturday to earn extra money. He spends 2 3/10 hours each day pulling weeds. How many total hours does Darby spend pulling weeds? So let's look at the important information. We know that he's pulling weeds 2 days, right? We've got Friday and Saturday. So that's going to be 2 days. And he spends 2 3/10 hours each day. So if I've got 2 days, he pulls 2.3 hours of weeds each day. How many total hours would that be? That would be 2 times 2 3/10. So I could do 2 3/10 times 2. So remember, when we're multiplying with decimals, we just pretend like the decimal isn't there. We're pretending that this is basically 23 times 2. So I've got 3 times 2, which is 6. And then 2 times 2, which is 4. But then I had one number to the right of my decimal, right? So I got to scoot my decimal over 1 space to the left. And I end up with 4 6/10 as my final answer. If I wanted to show this on a model, I could just show 2.3 twice, right? So if I start at 0, I would end up at 2.3, which would be 1, 2, 3, right here. Right here would be 2 3/10, right? So this... Oops, didn't make the jump enough. This would be Friday, right? If I add another 2 3/10, so 2 would land me at 4.3, which would be right here. But then 1, 2, 3 extra right here. So this would be Saturday. Together, that is 4.64 6/10, which would be answer choice A. So that's a way to solve this problem, either using the traditional algorithm or with the model. Let's look at our next question. Let's look at number 2. So we have that Danella put peach preserves in jars that hold 3 8/10 ounces each. She made enough preserves to fill 5 5/10 jars. Danella wrote this equation and drew this area model to find how many ounces of preserves she made. How many total ounces of preserves did Danella make? All right, so we could use this area model to solve, or we could solve it using the traditional algorithm. So let's look at our area model. So the top shows 5 5/10, right? Each one of these squares is one whole. So this is one whole. Each one of these bars that you see would be the 1/10, right? So if I've got 1, 2, 3, 4, 5 holes, and then 1, 2, 3, 4, 5/10. So one rod is 1/10. And then each of these squares then at the bottom that you see that overlap, each of these squares would represent 1/100th. So if I wanted to solve it using the area model, I can just count my wholes, my tenths, and my hundredths. Well, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 holes. So I've got 15 holes, which would just be 15 0/10, right? Now let's think about how many tenths we've got. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So plus another 8 right here would be 31. This 8 would be 39. This 8 would be 47. And this 8 would be 55. So I'd have 55 tenths. Remember, 10 tenths is one whole. So 55 tenths would be 5 and 5 tenths. And then I've got all these hundreds. I've got 1, 2, 3, 4, 5. I've got 5, 10, 15, 20, 25, 30, 35, 40. I've got 40 hundredths. So it'd be 0.40. So remember, with area models, our final step is to add them up, right? So I could just add up all the wholes, the tenths, and the hundredths that we had, and that would be my final answer. Add my placeholder zeros, and I end up with 0. 0 plus 5 plus 4 is 9. Add my decimal and my decimal line. 5 plus 5 plus 0 is 10. Carry the 1. 1 plus 1 is 2. So I end up with 20 and 90 hundredths. I don't see that, but remember, this 0 in hundredths is not necessary. So I end up with 20 and 9 tenths, which is G. If I wanted to just do normal multiplication, the normal algorithm, to check my work, I could totally do that. I could just do my problem that was right here. My 5 and 5 tenths times 3 and sorry y'all, I can't speak. 5 times 5 tenths. 5 and 5 tenths times 3 and 8 tenths. So I could do 5 and 5 tenths times 3 and 8 tenths. And just pretend that this is doing 55 times 38, right? So my first step is to multiply my 8 out. So 8 times 5 is 40. Carry the 4. 8 times 5 is 40, plus 4 is 44. So I multiply my 8 out. Now I got to drop to the next row. Add your placeholder smiley, so you don't forget. And then multiply your 3 out. So 3 times 5 is 15. 3 times 5 is 15 again, plus the 1 that we carried is 16. So then you add. 0 plus 0 is 0. 5 plus 4 is 9. 6 plus 4 is 10. Carry the 1. We get 2, but then we had 2 numbers to the right of our decimal, so we scooted over 1, 2, and I end up with the same answer. All right, let's look at our next one. So here we've got our hundreds grid that we were doing on Friday, right? We have that Cleo raked 8 tenths of the backyard. He mowed 7 tenths of the raked portion of the yard. The large square represents the backyard. Which decimal number represents the portion of the yard Cleo both raked and mowed? So let's look at our model, right? Our model is basically showing us 8 tenths times 7 tenths. Well, I've got my 8 tenths right here, right? This is my 8 tenths portion of the yard. That is how much was raked. Out of that 8 tenths, 7 tenths was mowed, right? So that would be this portion of the yard. The part that was both raked and mowed is our answer, which is the space that was overlapping, which would be this right here that I'm outlining in blue. So if I wanted to find my answer, I could just count those squares, right? I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56. 56 little squares. Remember, 56 little squares, each square represents 1/100th, so that would be 56 hundredths, which would be 0.56. 56 hundredths, which is C. Let's get to the next question. All right, so number 4. Number 4, we've got our problem, but we are wanting to find the model that represents the problem, right? So number 4 says that Stacy's mother baked 6 chocolate chip cookies. Each cookie contained 3 contained 2 and 3/10 grams of chocolate chips. Which model can be used to find the total number of grams of chocolate chips Stacy's mother used? So, if I am baking 6 chocolate chip cookies, right, and each cookie contains 2.3 grams of chocolate chips, I'm trying to find the total. That sounds like a multiplying, right? I'm doing 6 times 2 and 3/10. So I'm wanting to see 2 and 3/10 6 times. Remember, when we were talking about our models earlier, using our area models, we are saying that 1's whole square is 1 whole, right? A rod was 1/10, and then a little square was 1/100th, right? So let's try to see if we can find an area model where it shows 2 and 3/10 6 times, right? Well, let's look at F. So F is first. I've got 1, 2, 3, 4, 5, 6 wholes and 3/10. So that would be 6 and 3/10. But it's got it twice, so it'd be 6 and 3/10 times 2. That's not our problem, so that's not correct. Let's look at G. We've got 1, 2, 3, 4, 5, 6 holes up top. And then towards the side, we've got 1, 2 holes, and then 1, 2, 3/10. So this would be 6 times 2 and 3/10. That sounds good so far. Let's just double check the rest of them. H has 1, 2, 3 and 3/10 up top, and it's got 2 rows of it, so it'd be 3 and 3/10 times 2, which is not correct. J has 1, 2, 3, 4 times, and then on the side we've got 1, 2, and 1, 2, 3/10. So that'd be 4 times 2 and 3/10, which is not correct. So our answer would be G. G is the only one that shows an area model that matches this problem correctly. Let's look at our final question we're going to go over together. All right, so this is numbered as number 1. Just make sure that when you are looking at your problems, make sure that they are numbered correctly along with these ones that we're going over. So number 1 says that Sue runs a lap around the track in 2 and 5/10 minutes. She uses the model below to predict how many minutes it will take her to run 3 and 5/10 laps at the same speed. Which shows the number of minutes it will take Sue to run the laps? So this is like the question that we did earlier, right? Where we're trying to use the area model to solve the problem. So remember, we just talked about it, that 1 square is 1 hole. 1 rod, 1 bar is 1/10. Oh, that looks like teeth. 1/10. And then 1 little square is 1/100th. So if I wanted to use the area model, I could just add up all of my amounts, right? So we have 1, 2, 3, 4, 5, 6 holes, right? So that would be 6.0. Our tenths, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. 25 tenths. Remember, 10 tenths makes 1 whole, right? So 25 tenths is going to create 2 holes and 5 tenths, so 2.5. And then our hundredths, we just count. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. 25 hundredths, which would be written as 0.25. And then we just add them all up. We've got blank spaces right here, so let's add our placeholder zeros. And we're ready to add. 0 plus 0 plus 5 is 5. 0 plus 5 is 5, plus 2 is 7. Bring down our decimal into our answer. 6 plus 2 plus 0 is 8. So we've got 8 and 75 hundredths minutes for her to run all those laps, which would be B. If you wanted to do normal multiplication to solve this, you could just have done 2 and 5/10 times 3 and 5/10. just pretending that it's basically doing 25 times 35. So I'd multiply this 5 out first. I got 5 times 5 is 25. Carry the 2. 5 times 2 is 10 plus 2 is 12. Add my placeholder 0 in the next row so I don't accidentally put anything in that spot because I want my next answer to line up under my 3. So I'm going to multiply that 3 out. I have 3 times 5, which is 15. Carry the 1. 3 times 2 is 6 plus 1 is 7. And if I add those up, I get 5, 7, 8, but I still had 2 numbers to the right of my decimal, so it scoots over 1, 2, and I still end up with the same answer, 8 75/100. So your assignment today is going to be all about multiplying decimals together, using models, without models. The models might change depending on everything that we've done last week. So you might have some hundreds grids, you might have some area models. It just depends. So you use what you feel comfortable with to solve these problems, and we will go over it later. Let me know if y'all have any questions, and have a great day, guys. Bye. I'll talk to you later.